Right, so 401 is basically introducing the whole big idea of this unit. So our big idea of this unit is we need to find the solutions to a quadratic equation. Last unit, we were finding the graphs to a quadratic equation. So it's important to remember all solutions are just x-intercepts on the graphs. They might be referred to as solutions or a root or a zero or an x-intercept, but this is all interchangeable vocabulary. And so we are going to look at all these different strategies to find solutions to a quadratic equation. So guess which strategy is coming first? Graphing, because we just finished a unit on graphing. So let's look at some examples when you are solving quadratics graphically. You're just going to look at the graph and you're going to decide, hey, where did that graph cross the x-axis? So my x-intercepts are -1, 0, and 2, 0. My solutions, what x values will make this equation equal 0 when x equals -1 or +2? And let's just check that. -1 squared is 1, and then if I'm minusing a minus, I get a plus, right? So 1 plus 1 minus 2 is 0. It worked. Now I'm going to plug in 2. 2 squared is 4, minus 2 is also 0. So these are my solutions to this equation, and I read them directly off the graph of this equation. So there's only one x-intercept on this graph. Here's the function. It's in standard form. This person has already graphed the equation. So the x-intercept is at 5, 0. So the solution is that x must equal 5 to make this equation equal 0. 25 minus 50 plus 25 equals 0. What x-intercepts do you see on the next graph? I see an x-intercept at 1 and at 3. So I write that 1, 0 and 3, 0, or x equals 1 or +3. Do you see any x-intercepts on this graph? There are none, right? And so there's actually no solution to some quadratic equations. And remember, all a quadratic equation is that it has an x squared as the leading term. So this back page of 401 takes you through the path of a catapult projectile, which we've already studied. So I'm just going to skip down here. Here's a graph of a real life situation, and I just want you to answer this question for me. This graph is showing the ball hitting the ground after how many seconds? 3 seconds, right? So it says we will learn strategies to be able to solve this equation algebraically. So instead of looking at the graph, we are going to use all these different types of methods: factoring, square root, completing the square, and the quadratic formula. So your guided practice for 401 takes you through a review of graphing quadratics that are in vertex or standard form. So there are a few questions like that. Now, let's do the first one together to remember how to graph a parabola. This parabola has a transformation of down 4. This parabola has a transformation of right 1 and shrunk by a half. So let's find the x-intercepts of these two parabolas, and then I'll show you how to do it on a graphing calculator in case you forget how to graph these. This says start at -4 and do the parent function, right? 1x squared. Over 1, up 1, and over 2, up 1, 2, 3, 4. Did I just hit the x-axis? Yes, I did. So it says solve by graphing x equals -2 or +2. So make sure to write your x-intercepts. On number 2, this has been shifted right 1. So my vertex goes on the x-axis at 1, and the half makes me go over 1, up a half, over 2, up 2. Did I touch the x-axis? Yes, I did, at x equals 1. So you're going to go through the rest of the examples and you're going to graph. Now, what if you forget how to graph one of these equations, but you have a graphing calculator handy? You're going to go to your y equals menu and clear out what's in there, and I'm going to graph this function x squared minus 4. So if I graph x squared minus 4, and then I'm just going to hit zoom 6 to show the graph, can I read the x-intercepts right off of that? Sure I can, right? So if I read the x-intercepts right off of that, they're at -2 and 2. So don't let forgetting how to graph prevent you from finishing the rest of this work on 401. Rely on your graphing calculator.